Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series on mechanical properties of fluids. Right now we are completed the Pascal's law, and according to Pascal's law, when we provide a force, we provide a pressure at one point, it is transmitted equally and without undiminished to the all points in the fluid or every point in the fluid. Now according to that Pascal's law, we have to going with applications of that Pascal's law. First application is nothing but a hydraulic lift. Inside the hydraulic lift, the mechanism of that hydraulic lift is based on the Pascal's law. That means it is based on Pascal's law. It is based on Pascal's law, and it is used to lift. It is used to lift heavy object using small force. This is the consideration of hydraulic lift, and hydraulic lift depends on, or its mechanism is based on that Pascal's law, and it is used to lift the heavy object by using a small force. Right now we are going with the consideration of it contain a tank with the fluid. Contain tank with fluid with and two pistons S1 and S2 having a different cross sectional area, having A1 and A2 are cross sectional areas, and A1 is very less than A2. That means area of cross section of S2 is very large than area of cross section S1, and therefore inside this A1 is having very small area than A2, and therefore A1 is very less than A2. If F1 be the force applied to S1, that means F1 be the force applied to the S1. At that time piston S1 is pushes inside, and at that time if F1 be the force applied to S1, then pressure P1 is equal to F divided by A1 is here. F1 divided by A1 is here. And this force is applied at S1. According to Pascal's law, it is provided at a second piston, that means S2, and which is lifted or which is moved in a outward direction. Let her to consider F2 be the force which is acted in upward direction due to that downward force F1. F2 be the force acted upward direction due to that downward force F1 is here, and P1 and P2 be the pressures. According to Pascal's law, pressure applied at one point, it is similar at the pressure which is transmitted equally and without diminishing to the another point, and therefore P1 is equal to P2 is here, and therefore you have to consider, let us consider P1 is equal to P2 is equal to P. That means P is equal to F1 divided by A1 is here. F1 divided by A1 is here. Now we know that the consideration of therefore Therefore you will get the consideration is here, and F2 be the force, and it is a once again I'm speaking that according to Pascal's law, this pressure is transmitted to the piston S2 without diminishing, without diminishing, and therefore you will get the P1 is equal to P2 is equal to P is here, and P is equal to F1 divided by A is here, and therefore F2 is equal to, therefore F2 is equal to P2 into A2, but P2 is equal to P1 is equal to P, that means F divided by A, and therefore P2 is putted at here, F1 divided by A1 into A2 is here, and as per consideration of A2 is very greater than A1, this division, therefore F2 is very greater than F1 is here. F2 is very greater than F1 is here, and it is used to lift, and it is used to lift heavy object using smaller force, that is F1, and this is your principle. That means a heavy load can be placed on S2, heavy load can be placed on S2 piston, and we apply a small force at S1 piston. This heavy load can be easily lifted by using that small force is here, and this is nothing but a principle of hydraulic lift is here. That means you can apply a small force. I'm taking consideration is here, applying small force lift heavy object, and this is nothing but a principle of hydraulic lift is there. Now second application is nothing but second application of that Pascal's law is hydraulic brakes. Hydraulic brakes having the diagrammatic representation as here it contain 4 slave cylinders and 1 master cylinder is here. Master cylinder having area of cross section A1, and slave cylinders have area of cross section A2 is there, and area of cross section A1 is very small as compared to A2. Area of cross section of slave cylinders, and here brake pedal is provided to the master cylinder. When we provide a force F1 to that cylinder, F1 to that piston, at that time fluid is maintaining the pressure, and according to Pascal's law, the pressure created at this master cylinder, it is equally and without diminishing provided at the slave cylinders, and which creates a force which is greater than the force provided by the F1 cylinder, and it is your principle related to that hydraulic brakes is there. And right now we have to consider what is the hydraulic brakes working and how it is giving the small force, and small force is converted into large force, and which is provided to that slave cylinders, and from and force is small force provided at the master cylinder is there. Right now we have to get the consideration related to that one. First of all, it hydraulic brakes what is the use of that one? It is used to, it is what is it? It is nothing but a hydraulic brakes. It is used to slow down or stop the motion of vehicle. It is based on principle as that of hydraulic lift is there, or it is also work on the principle of Pascal's law, or statement of Pascal's law is there. In a schematic diagram, we know that the master cylinder provided with a brake, and a small force F1 is applied on that brake pedal, and at that time master saw create the pressure, and this pressure is provided to all slave cylinders equally and without diminishing, and which creates the larger force, and this force is these pistons are connected to these pistons are slave cylinders are connected to the friction pad, and those friction pads are in contact with the rotational disc, and due to that frictions in between friction pad and rotational disc, motion of vehicle is slowed down, or vehicle may be stopped there, and it is written as like that one: by pressing brake pedal piston of master cylinder push forward by force F1 is there. As a result pistons of slave cylinders also move forward attached to friction pads are in contact with rotational disc. Rotating disc is there, and which connected to, and this rotation disc which is connected to wheel, and thus due to that friction pads and which is connected to rotation disc, and rotation disc is connected to wheel, the motion of vehicle slow down or maybe stop is there, and this is done by using the consideration of that schematic consideration. Later to consider, let A1 area of master cylinder is smaller than A2 be the area of Slav cylinder. And now by applying that F1 force, by applying F1 force, F1, and it is a smaller one, small force is there, F1 force, we will get the pressure. We generate pressure as P is equal to F1 divided by A1 is there, and it is transmitted through hydraulic tubes to the Slav cylinder without diminishing. What is the diminishing? Diminishing is nothing but a decreasing. Without decreasing that pressure is nothing but P is equal to F1 divided by A1 is transmitted to the hydraulic tube, and it is reaches to the Slav cylinder without diminishing, and generates, and therefore the force F2 on Slav cylinder A2, it is equal to F1 into here. F1 A2 divided by A1 is here. We know that the A1 is very small as compared to A2, and therefore this quantity or this force is greater than F1, and therefore F1 is less than F2. F1 is less than F2. F2 is there, and this F2 is greater as compared to that of F1, and due to providing a small force applied to the brake pedal, thus small force F1 applied to brake pedal, we generate we convert it into large force and slow down or stop the vehicle. And those are the two applications related to Pascal's law, and according to that one you have to get the schematically when we applying a small force F1 at the master cylinder, then this force is force create the pressure P, which is transmitted to the Slav cylinders without diminishing, that means without decreasing, and at the Slav cylinder you will get the force F2, which is very greater than F1 because area A2 is greater than area A1 is here, and therefore you will get the small force is applied to the brake pedal. We can convert it into the large force, and you can slow down the vehicle or stop the vehicle by using a hydraulic brakes. And this is your applications of Pascal's law. First application is nothing but a hydraulic lift. Inside this you have to provide a small force and lift the heavy object by using a small force, and in hydraulic brakes providing a small force you can generate the large force at the Slav cylinders and stop the vehicle or slow down the vehicle. This is your consideration of application of Pascal's law. And if you like that video, please subscribe my channel and press on bell icon to get the next notification related to lecture series of mechanical properties of fluids. Thank you.